Hey everyone, we are working on probability of independent and dependent events. So follow along and take notes. So when we talk about independent events or dependent events, we're talking about compound events or more than one thing happening, and we want the probability of that. So we know, hopefully, this first one, which is probability is the chance that some event can occur. When one event does not affect the outcome of the other event, the events are called independent events. And I will explain that in just a second. Independent events. So what that means is when one thing does not affect the other. That would be like if you're rolling a number cube. If I roll a 6, when I roll that number cube again, I have the same chance of rolling a 6 because that 6 does not disappear, okay? Or if I have a spinner, you see a spinner shown below. It has A, B, C, or you can look at colors yellow, yellow, red, and blue. So if I spin the spinner and it lands on an A, when I spin the spinner again, I have the same probability of landing on an A. The A does not disappear. The section does not get smaller. I can keep spinning and keep spinning, and each one of these have a 1/3 chance of occurring with each spin. And then, of course, we have coins. Okay, whenever I have a coin, I can flip it and get a heads. When I flip it again, I can get a heads. When I flip it again, I can get a heads. It doesn't disappear. Okay, so those are independent. One thing does not affect the other. The other word I want to make sure you see here is with replacement, which means we're going to put it back, or even if it says replace. Okay. So when I put something back, that means that total is not going to change. So that's kind of what I like to focus on when we are doing these problems. So now, and I really like these two problems that you see here. It says one letter tile is selected right here, and the spinner is spun. What is the probability that both will be a vowel? So we can tell we are doing two things here, okay? So I always put probability, and then I put the two things. I never put the word both. That's going to mess us up. I always put vowel, then another vowel. I'm putting a V for a vowel. So this is telling me I want the probability of a vowel and then another vowel, okay? So, and hopefully we remember a vowel is A, E, I, O, U, and sometimes Y. I'm going to tell you in math, they're not going to try to trick you. These are the vowels they're going to use unless they specifically tell you Y will count as a vowel. Okay? So, I'm going to do my event 1. These are completely separate events. Okay? So I'm looking right here. I want the probability of a vowel. That's what I want. This is my event. So when I look here, remember we always want that total first, which is 4. 1, 2, 3, 4. Then I'm looking for vowels. 1, 2. Those are consonants. Okay. So there is a 2 out of 4 chance, which hopefully we know simplifies to 1/2. There's basically a 50-50 chance of getting a vowel on what they showed us. Okay. So I usually try to simplify this if I can think about it, but I definitely try to do it before I get to my last step, which I will explain momentarily. So event 2, I look right here. I still want a vowel. A, B, C. I only see one vowel. On this spinner, there are 3 equal sections. Okay, I want to make sure I recognize that. So there's a total of 3 and 1 is a vowel. Okay. Once I do this, since I already simplified here, I have a 1 on top and a 1 on top on both, so I cannot go any further. Once I have these two fractions, I multiply. I take the simplified fraction, 1/2 times 1 over 3 in its basic multiplication. 1 times 1, 2 times 3. And we know that won't simplify because there's a 1 on top. So now let's look at the second problem. This one is where it says one event does affect. If the outcome of one event affects the outcome of another event, the events are called dependent events. And I'm going to explain that because you have to look kind of for keywords to know if it's dependent. An example would be when you do not replace an item after you select one. Okay, so here's an example of that. And we're going to go with the wording and the situation on this. Okay, so this says there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. So what I'm going to do is just make kind of a makeshift sample space here. I'm going to put O, 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 O. That will be for the oranges. Bananas, I have 7. And then we have 5 apples. Okay. It says Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Determine the probabilities that 2 apples are chosen. So we have 2 people choosing. We want 2 apples. I'm not going to put 2 apples. I'm going to put apple, then apple again. Okay. So we need event 1, event 2, because 2 people are doing things. So on this one, we're going to make an assumption here. Okay. We're going to talk about this. So it says Ignacio selects a piece of fruit. So Ignacio, it says he wants an apple because we want 2 apples. Okay. So Ignacio selects a fruit. Oh, I messed up. I didn't put 5 apples there. Okay. So remember the first thing we want is a total. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or I can say 4 plus 7 plus 5, which is 16. Okay. He reaches in. He takes 1 piece. And basically, remember, he wants an apple. So we're trying to figure out what is the chance he's getting an apple. So, and I know this sounds silly because we know what an apple feels like. So we're just going to pretend these are in little sacks that we can't tell what they are. So we have 5 chances to get an apple. Okay. This will not simplify. 5 is prime. It is not a factor of 16. Okay. Now, we're also going to assume that Ignacio is choosing a piece of fruit to eat, which means he is taking the apple and he will not replace it. So I'm getting rid of 1 apple. Well, when I do that, that changes the total. 4 plus 7, which is 11. 11 plus 4 is 15. Okay. Now, Ignacio reaches in and he wants an apple also. What is the chance? He has 4 chances is what I see of getting an apple. Okay. There are 4 left. We are only taking 1, but we're looking at the number of chances. Okay. So we do event 1, event 2, and multiply. So I'm going to try to multiply these. These fractions by themselves will not simplify, but what you will notice is when I put them down, you should be able to see this relationship. Now, if you don't see it, multiply across the top, multiply across the bottom, and then you should, if nothing else, be able to see a 0 you can cross out, and then you can do something else to simplify. But here, I would say, I know 5 and 15. These work together. These both divide by 5. 5 divided by 5, 1. 15 divided by 5, 3. And that's not it, because I know 4 and 16 work together. If for no other reason, then they're both even. They could divide by 2. But also they divide by 4. 4 divided by 4 is a 1. 16 divided by 4 is 4. Okay? So that makes a giant difference in trying to not make a silly mistake when we're doing this, okay? So I have 1 times 1, 4 times 3. And I know I cannot go any further because 1 is as far as we can go. 1 and done. That is the end, okay? So when you're doing more than one event, you find the probability of each event and then multiply.